All right, hey everyone. This is Leetcode Fun Test 512. So, if at most n digits and whose sum of digits is s, return -1. Okay. So write int max equal to 9 times n. If max is less than s, return -1. And then we can while n minus minus. If s greater than or equal to 9, answer 0, answer plus equal to 9. Else, answer plus equal to s is equal to 0. Return answer. 90, -1, and 0. Alright. Aggregate 2 time series. Given two 2D integer arrays, series 1 and series 2, each element in both series is of the form timestamp and value, where timestamp is an integer representing the time, value is an integer representing the value at that timestamp. Each array is sorted in strictly increasing order of timestamp. Okay. For any timestamp not present, its value is taken from the next available timestamp in the same series if one exists. Otherwise, it's considered 0. Okay, a series is formed by summing the corresponding values from both series at every timestamp that appears in either series. Okay. 1, 3, okay, 2, so it came from 2. Timestamps are up to 10 to the 9. Okay. 3 plus 2, and then this is 1, came from 1, 2, 4, okay, and then 5 is 0. So I think 2 pointers. Just write this A and this is B. Okay. If AI, okay, they're all distinct, right? They're strictly increasing, so they're distinct. If AI 0 is less than BI 0, answer, okay, answer dot pushback. Should be AI 0 and AI 1 plus BI 1. Else if AI 0 equal BI 0, BJ. And I plus plus, insert a pushback. It should be the same thing, except I and J both plus plus. Otherwise, we can just do a BJ0, AI1 plus BJ1, and J plus plus. If okay, while I is smaller than n, insert dot pushback AI0, AI1, I plus plus, right? While J is less than M, insert a pushback BJ0, BJ1, J++, return answer. 1523432 17231 17. Okay. Next one. To positive ending k, a valid sequence is a sequence of k positive integers such that the sum is equal to n and the product is even. So at least one even. Return the number of valid sequences. Since the answer may be large, return modulo n to the 9 plus 7. Okay. This is easy. Okay, so first of all, right, we need combinatorics. So I can have pick this and we take this. Okay. 5 times 10 to the 5. We only need it up to n. So okay. Um, right. Basically find the total number. So long top. Total should be A1 all the way to AK is equal to n, and they're all greater than or equal to 1. So choose n minus 1, choose k minus 1. And then we subtract the ones that are all odd. Right, so if all of them are odd, we can subtract. Okay, so we n minus k divided by 2 and k minus 1. And top minus equal to sub, return top. That's right. 5, 3, so 1, 2, 2, no. If we add 1 to all of them, then our sum, okay, so n plus k. So 4 and 2, so 6. Right, 1, 1, 1, 3, minus 1. Yeah. 3, 2, 0. Alright, nice. Next one. Given two integers m and n, representing the number of rows and columns of a grid, your goal is to reach cell m-1, n-1. You are also given a 2D integer array penalty. The cost to enter cell ij is i+1 times j+1. You begin at cell 00 and initially pay its entrance costs. Actions performed after entering 00 are numbered starting from 1. On each action, you may move to an adjacent cell or wait in the current cell. A move follows the priority rule if, an odd, you move right or down, and even you move left or up. Okay. The cost is, if you move, then a priority rule, then it's only the entrance cost. If it violates, you pay the entrance cost plus penalty IJ. If you wait, you pay penalty IJ. Okay. After each move or wait, the action number increases by 1. Therefore, the required priority alternates after every action, regardless of whether. Okay, so okay, I think this is just you can use shortest paths, right? Or just DP is fine also. Okay. Okay. One E18. So we need long long. Okay. We start dp00 equals 0. dp000, right? We start of entry cost 1, move down. No, it should be first move. Q. Q dot front. Q dot pop. Cur 0. Y equals cur 1. Direction equals cur 2. Or party. What is right par? Okay. Long cost. First it should be penalty. Penalty current, right? Penalty XY. Okay, and then if you move somewhere else, then you have to also add a penalty. If the par is not equal to, okay, if direction, if int next equals x plus dxter, new y equals y plus uy and direction, right? This has to be valid. So if 0 smaller, if mx is smaller than 0, x greater than m, or my smaller than 0, or n greater than equal to n, we can continue. Okay. If nx is equal to x, and par is equal to on even, okay, on odd is right or down. So dir is equal to blank, or dir is equal to blank. If party is 0, which means it's even, you move left or up. So right or down. Right is 4. Right is 3. And down is right is y plus plus. So it should be 2 or 3. Pay the entrance cost of the destination cell. What is the entrance cost? It's I plus 1 times j plus 1. Okay. If cost is less than dp new x new y par x1, dp new x new y par x1 is equal to cost q dot push next par 1. Okay, 5. Okay, so there's a small bug. Um, we start with 0, 0, 1. Oh, you have also the entry cost at 0, 0, right? Pay only the entrance cost. So if you you can also wait. I forgot to account for that. If you wait, dpxy par 1. If you wait, it's penalty. Okay. Plus dpxy xy par 8, 7, and PLE. Okay. It changes to a shortest paths, right? You can use the shortest paths. Par equals to 3. Okay. Does this fix it? Oh, you got a cost. A712. All right. So yeah, 256. Okay, yeah, I did pretty good today. I'm gonna go over the solutions. I feel like this contest was really mathy. Like uh I think top 200 after yeah, 200. Okay, so um solutions. So first for Q1, um okay. Basically, it's always better to put more nines in front, right? You'd rather have 99900 than, let's say, 99810. So basically, the greedy algorithm, um, first you check if it's valid. The max is just a bunch of nines together, so the max sum is 9 times n. If our target s is greater than this max, we can return -1. Otherwise, we use a greedy algorithm. We start with our answer. For every digit, we do answer times equal to 10. If s is greater than or equal to 9, we answer plus equal to 9 and s minus equal to 9. And otherwise, answer plus equal to s and s is equal to 0. This can also be changed to answer plus equal to min 9s, s minus equal to min 9s. This also works. And after all of this, we can just return answer. It's just a greedy algorithm. Over here, we just construct it. We try to put the nines in front as much as possible, right? We try to put greater numbers, more front, basically. Next one. Okay, so this is a two pointers. Um, so what this problem basically asks you for is for you to combine these two into one large time span. Time span. Yeah. So what I did was I used two pointers because we know that they're sorted. We start with I and J. We calculate the sizes. We have our answer array. So while I is less than n and j is less than m, if ai0 is less than bi0, then bj0. For example, 1 and 2, right, 1 is less than 2. What we're gonna do is we're gonna have ai0 as our timestamp, and what I found was the answer will always be the same. So you can replace this with um, a val is this, right? You can replace all of these with val, right? Um, if AI0 is less than BJ0, you can just the timestamp will be the minimum of AI0 and BI0, basically. So insert a pushback min AI0 BJ0 and val. So you can just do this, and then you can ignore all of these, and just like that. Right? The new timestamp will be the minimum of them, and then the value will be AI1 plus BJ1. And then now we just gotta see, do we increment I or do we increment J or both, right? If AI0 is less than BJ0, then we used AI, so I plus plus. If they're both equal, we use both of them, so they both plus plus. Otherwise, J plus plus, all right? At the end, right, sometimes you can have J is less than M or I is less than N. So you gotta iterate over I and J. While I is less than N, we just push back AI and then I plus plus. And while J is less than M, answer dot push back BJ and J plus plus. And you can just return answer, and it will always be sorted at the end. So yeah, it's all pretty simple. Q3 is just a math problem. Uh, okay. So but you want to find the number of sequences such that the sum is equal to n and the product is even. So first, what I did was I found the total number. So I looked at the problem and I was like, right, it's even, but odd is way easier to calculate because odd just means every single value is odd. So I just changed the problem to calculating the total number subtracted by the number of sequences with all odd integers. So some knowledge that you should know is A1 plus A2 plus A3 plus all the way to AN. If this is equal to K, the number of solutions will be equal to C n minus 1 K minus 1. Right, this is just some knowledge that you should know before doing this problem. So all of this and this is just basically helping me calculate this choose method. Um, and then now we start with the actual solution, right? The total is choose n minus 1 K minus 1. And then when is it possible such that we can make all of them odd? Well, you need n divided by n, the party of n equals to the party of k. Right? Because think of this, right? If they're all odd, right? If all are odd, then what I do is I add 1 to everything. Add 1 to every number. So what you get um a1 plus 1 plus a2 plus 1 plus a3 plus 1 plus a4 plus 1 plus all the way to an plus 1 is equal to k plus n because you add n to each side in total. Now you can divide by 2 on each side. So we let a um, a idx sharp, right? We can let this be a idx plus 1 divided by 2. So a idx sharp a1 sharp plus a2 sharp plus a3 sharp plus a4 sharp all the way to a n sharp should be equal to um, k plus n divided by 2. And now you realize that um, a idx sharp should all be greater than or equal to 1. And they're all positive integers. So now we just change it to this problem. So num solutions is choose k plus n divided by 2 and k minus 1. So right over here you can see that you need n and k to have the same parity, so they sum to even value, and you can divide by 2. So you need just calculate the number you have to subtract, and then you subtract it from total, and then you can just return your total. So key thing is just to add 1 to just see this, um, and just be good at math, I think. Okay. Q4. Um. Okay, so when you Q4 is just a DP or shortest path problem. Well, I just use a DP-ish solution, I think. Um, yeah, so in this problem, you have some edges, right? You have edges from every two adjacent um grid squares, and then you want to find the minimum cost to move from 0, 0 to m minus 1 and n minus 1. So I'm just doing what the problem says. I have my DP array, m, n, and 2, because we have to account for the parity of the move number, right? You start at 0, 0, 1. I have this priority queue. I push. What do I push? I push value. I push value, x, y, and the parity. So, right, you iterate while the priority queue is not empty. So there are two ways to move from this. One way is to go from this party to party X or 1. The other one is to move to an adjacent cell, right? So you can stick to the current cell or you can move to an adjacent cell. The first step, right, if you want to stay in this cell, the new cost, right, we're just doing what the problem statement says, is dp xy par plus penalty xy. And I think the reason I got wrong and TLE at the beginning was I didn't add 0 long long, right? I think Q would still work here. But yeah. So you have your long long C, and then if C, right, this cost is less than dp xy parent xr1, dp xy parent xr1 equals C, and you can push this next point, next node, right, into the priority queue. And then next up, you have your directions, right? You move to an adjacent cell. So you have our dx and dy. You have your new x and new y, right? So you first check if it's out of bounds, right? If it's out of bounds, you can't continue from there. So if it's out of bounds, you can continue to the next adjacent cell. Otherwise, you can try calculating the cost, right, and updating it. So currently the cost will be 1 long long times nx plus 1 times ny plus 1 plus dp xy par, right? Because the problem statement says that first you gotta add this dp xy par, and then you gotta add the entrance fee. So if par is equal to 0 and dir is equal to 2 or dir equals 3, or par is equal to 1 and dir equals 0 or dir equals 2, we add the penalty, right? What does this mean? What this means is if par is equal to 0, right, then it's an even number action. You shouldn't move left or up. So if you move right or down on the even number action, then you accumulate penalty ij. And if it's odd, so par is equal to 1, if you move left or up, then you will accumulate this parity with this penalty ij. So if parity equals 0, which is even, right should be this, like I dir equals 2, and up should be dir equals 3. So if dir equals 2 or dir equals 3 and parity equals 0, then we have to add this penalty. Same thing if parity equals 1, then if dir equals 0 or dir equals 1, we have to add this penalty also. And then we can just update it, right? If cost is less than dp and x and y parity xor1, we can update our dp, and we can push this cell into priority queue. After we're all done with all of that, we can just return the minimum of dp n minus 1 n minus 1 0 and dp n minus 1 n minus 1 l 1, right? Because this is the one where you finish with a even party, and this is the one where you finish with a odd party, and you gotta take the minimum of those two. So yeah, that's Q4. So this is Leetcode weekly contest 512. I did really good. So yeah, I'll upload this after the contest ends.